Welcome to the lecture number 42, dear students. As I stated in the last lecture, that in this lecture number 42, I am going to explain you very important theorem. It is called as theorem of areas of similar triangles. I repeat again the statement. Theorem of areas of similar triangles. Why I read it again, that also I tell you. The reason being that you have to understand this concept, and this concept is very important, that similar triangles. So this theorem is applicable if and only if triangles are similar. This is very important concept you have to understand. Again, I stressfully says that similar triangles. This word is very important. Okay. Now you will find I am going to read this. I have written or copied it same as it is given in the textbook. So there is no problem that you should also copy down the same. Now I will come to the explanation. Statement. When two triangles are similar. See, this first line is only very important, that when two triangles are similar, the ratio of areas of those triangles is equal to the ratio of the squares of their, this is also very important one. What is it? Corresponding sides. So this is how you will find, dear students, that two triangles are given, namely triangle ABC and triangle PQR. These are similar triangles. This is very important, that triangles are similar. Fine. So in given triangle ABC similar to triangle PQR, then AB is perpendicular to BC, PS is perpendicular to QR, then area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon AR square. Now what is important thing? Important thing is these are corresponding sides of similar triangles. Very important. These are corresponding sides of similar triangles. So you will find here AB one-to-one correspondence exists with PQ, BC one-to-one correspondence with QR, and AC one-to-one correspondence with AR. And therefore, if triangles are similar, then ratio of areas of triangles proportional to the square of corresponding sides. That one is very important, corresponding sides. Okay, so this is how you will find that these are the things that we have to prove. Now let's come to this proof now. Area of triangle ABC upon area of triangle PQR. This is our triangle ABC. This is our triangle PQR. That is equal to BC into AD. BC into AD upon QR into PS. We all have studied at the beginning of this chapter only that areas of the triangles are proportional to the product of base and height. And in this case, what is the base of ABC? Base is BC. What is height of ABC? Is AB. What is the base of PQR? Is QR. And what is the height of PS? Height is PS. Therefore, ratio of areas of triangles is equal to product of base and height. Product of base and height. Whatever is written over here, same things are written over here, only in split form. BC upon QR separately is separated by AD upon PS. Okay, so you will find BC upon QR into AD upon PS. This is our equation 1. This is our equation 1. Now let's come to the next one. A triangle ABD and triangle PQS. Let's see here. A, B, D and triangle PQS. Okay. Now they have said B is congruent with Q given. Difficult to understand. Nowhere in the given it is given. Nowhere. But you have to understand, since triangle ABC similar to triangle PQR, therefore B is congruent with Q corresponding angles of similar triangles. This is very important to understand, that B is congruent with Q or B is equal to Q is given, reason being that triangle ABC similar to triangle PQR and therefore B is congruent with Q. Correct? Now you have to focus on two triangles ABD and PQS. Let's come over here. ABC and PQS. Why B is congruent with Q? This is important to understand. Though it is given, right? It is given. Why it comes under heading as given? Reason being that ABC similar to PQR. Fine. Now you will find in triangle ABD, this much only, this part only, and triangle PQS and triangle PQS. So B is congruent with Q. B is congruent with Q. Given. Why given? Because triangle ABC similar to triangle PQR. Fine. Now we will find the next one is ADB is equal to PSQ is equal to 90. Please have a look here. ADB. This is our triangle. ADB and angle PSQ. Each one of them is 90. Yes, ADB is equal to PSQ is equal to 90. And therefore you will find, according to AA test, what AA test says? When two angles of one triangle are respectively congruent with two angles of another triangle, then those two triangles are similar by AA test. Okay. So you will find that B is congruent with Q. D is congruent with S, and therefore we'll find each is 90. So according to AA test, triangle ABD is similar to triangle PQS. Correct? Now you will find, but it is given. That's true. That triangle ABC is similar to triangle PQR. Yes, it is absolutely correct. It is given. And that is why we get a very important result. AB upon PQ is equal to BC upon QR. AB upon PQ is equal to BC upon QR. Why? Corresponding sides of similar triangles. When triangles are similar, then their corresponding sides are also in ratio. Ratio of the corresponding sides are same. Okay. Now this is third. Fine. Now come to the next one. What is written over here? From 1, 2 and 3. Okay. Let's see result 1. Result 1 is BC upon QR is equal to A into AB upon PS. But AB upon PS is equal to AB upon PQ. But AB upon PQ is equal to BC upon QR. Very interesting. You will find the first one is BC upon QR is equal into AB upon PS. But AB upon PS is equal to AB upon PQ. So I can replace this AB upon PS in equation 1 by what? AB upon PQ. AB upon. And moreover to that, in the next step, this AB upon PQ can be replaced by BC upon QR. Very important. Very important. So in the first step, BC upon QR into AB upon PS. Okay. So you will find in the next step, we can replace AB upon PS is equal to AB upon PQ. Fine. And AB upon PQ can be replaced later on by BC upon QR. Then area of triangle ABC upon area of triangle PQR is equal to BC upon QR, BC upon QR into area upon PS into area upon PS. But this area upon PS we can write it as BC upon QR. That is very, very important. So you will get here area upon PS is replaced by BC upon QR. You will be getting BC square upon QR square. Correct? So you will find here AB square upon BQ square is equal to AC square upon PR square. So if what is the statement? Statement is very important. That ratio of areas of similar triangles. This is very important word. Repeatedly I am telling you the same thing. What happens in examination also? Many good students always get confused. That area is always product of base and height. Area is proportional to product of base and height. Absolutely correct. But if triangles are similar, then you have to use which formula? That areas are proportional to the square of their corresponding sides. So this difference you have to understand very, very clearly. If triangles are not similar, then you have to use the property where areas are proportional to product of base and height. But if somehow you prove triangles similar, then you can use this theorem on areas of similar triangles. This is also very, very important theorem from examination point of view. Reason being that because it's a very big theorem and there are 3 to 4 steps are also there. Statement figure given to prove that and all will surely sum up for 4 marks. This is how we as students will find that we have to understand this theorem properly. Now I am going to begin exercise 1.4. I am going to begin exercise 1.4. This is the last exercise of this chapter. Later on you will find we are going to begin problem set 1. Problem set 1. So there are these 2 theorems which are very important from this chapter. That first one, you all know that basic proportionality theorem is one of them. This is the second one, that areas of similar triangles. Theorem of areas of similar triangles. So practice it 1.4. The ratio of corresponding sides. The ratio, first question. The ratio of corresponding sides. The ratio of corresponding sides. Corresponding sides of similar triangles. Of similar triangles. Is 3:5. Is 3:5. Find the ratio of their areas. the ratio of their areas. Okay, now we will find the ratio of corresponding sides of, again, similar triangles. That is very important. So, let areas of similar triangles, areas of similar triangles be A1 and A2. Let areas of similar triangles be A1 and A2. Okay? So you will find the ratio of corresponding sides of similar triangles is 3:5. What? Corresponding sides. So A1 upon A2 is equal to S1 square upon S2 square. Triangles are similar. Their areas they are taken A1 and A2 is directly proportional to the square of their corresponding sides. So here I mention theorem on areas of similar triangles. Theorem on areas of similar triangles. Okay, so A1 upon A2 is equal to S1 upon S2. A1 upon A2 is equal to S1 square upon S2 square. So 3 square upon 5 square. That is equal to 9 upon 25. So A1 upon A2 is equal to 9 upon 25, because question asked is find the ratio of their areas. Very simple sum. This will surely come for 1 mark only, not even more than that. Okay. Question number 2. Question number 2. If triangle ABC similar to triangle PQR, and AB is to PQ, AD is to PQ is equal to 2:3. Then fill in the blanks is there. That's all. No issue as such. So naturally you will find area of triangle ABC. Area of triangle ABC upon area of triangle PQR is equal to theorem on areas of similar triangles. Okay. So area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square. That is equal to 2 square upon 3 square. Because triangles are given similar. Again, I would like to tell you the same thing. What is important thing? Triangles must be similar. Then and then only you can apply this theorem. So what is given? Triangle ABC. This is very important. Similar to triangle PQR. Therefore, area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square. That is equal to 4 upon 9. Okay, so theorem on areas of similar triangles. Theorem on areas of similar triangles. This is second. Third one. Third one is, if triangle ABC is similar to triangle PQR. If triangle ABC is similar to triangle PQR. If triangle ABC is similar to triangle PQR. This is question number 3 of exercise 1.4, page 25. Okay. Triangle ABC is similar to triangle PQR. Area of triangle ABC is 80. Area of triangle ABC is equal to 80. Next to that, area of triangle PQR, area of triangle PQR is equal to 125. 125. Area of triangle ABC is similar to triangle PQR. Area of triangle ABC is 80. Area of triangle PQR is 125. Fine. Then question asks is, fill in the blanks are there. Area of triangle ABC. Area of triangle ABC upon area of triangle PQR is equal to area of triangle ABC upon area of triangle PQR is equal to, right, is equal to 80 upon 125. 80 upon 125. Next to that, that's all. This is like fill in the blank type of question is there. If you wish to divide this, you can surely divide it by 5, because since you all know by the divisibility test of 5 that if the ending digit are 0 or 5, we can surely divide it by 5. Okay. Now next to that is question number 4. I am going to do now question number 4. This is 1 mark question. Question number 3 is of 1 mark. Now question number 4. Question number 4 is, triangle LMN similar to triangle PQR. Triangle LMN similar to triangle PQR. 9 times area of triangle PQR is equal to 16 times area of triangle LMN. If QR is 20, if QR is 20, question is find MN. Okay, find MN. Find MN. In this exercise again, it is very important to know a very important fact. Triangle element similar to triangle PQ. Triangle element is similar to triangle PQ. Okay. Fine. So we have to find out mn. I am going to apply theorem again. So you will find whatever is given 9 times area of triangle PQR is equal to 16 times area of triangle LN. So 9 times area of triangle PQR is equal to 16 times area of triangle LNN. So you will find here, find the n in there, say. Find n. Now please try to understand. Okay. Now I can write it as 9 from here. 16 this side is equal to 9 upon 16. 9 upon 16 is equal to area of triangle LNN upon area of triangle PQR. Is that clear? LNN upon PQR is equal to 9 upon 16. Our interest is to find out MN. Okay, therefore MN square upon QR square. MN square upon QR square. Theorem on areas of similar triangles, very important. Theorem on areas of similar triangles. Theorem on areas of similar triangles. 9 upon 16 is equal to area of triangle LNN upon area of triangle PQR is equal to MN square upon QR square. So okay, fine. So next to that we will be getting 9 upon 16. 9 upon 16. Nine upon 16 is equal to MN square upon QR square. 9 upon 16 is equal to MN square upon QR square. 9 upon 16 is equal to MN square upon QR square. Come back to the question. If QR is 20, okay, so 9 upon 16 is equal to MN square upon, right? QR is 20, so 20 square. So 9 upon 16 is equal to MN square upon 400. Very, very important. 9 upon 16 is equal to MN square upon 400. So you'll find that 9 upon 16 into 400 is equal to MN square. 9 upon 16 into 400, that is equal to MN square. So here you'll find 16 twos are and 16 5s. 16 twos are 32, 16 5s are 80. Then you will get MN square. MN square is equal to 225. MN square is equal to 225. Taking square root from both sides. Taking square root from both sides. So MN is root 225. So MN is equal to square root of 225 is 15. So this is how you will find MN is equal to 15. Very simple. Important step is here that 9 upon 16 is equal to area of triangle LMN upon triangle PQR is equal to MN square upon QR square. Then rest of the things. And what is important, even you will find that MN square upon QR square only you have to take, since we have to find out MN and QR is given. Otherwise, even though you will find absolutely correct that PQ square upon LN square as well as PR square upon LN square, these all are applicable. But our aim is to get value of MN, and that is why I have taken MN. Okay. Now let's do the next one. This is question number 4. Of course, weightage for this question will be of 3 marks. Weightage for this question will be of 3 marks. Now question number 5. Question number 5. In question number 5, areas of two similar triangles are areas of two similar triangles are areas of two similar triangles. Areas of two similar triangles are 225 square centimeter, 225 square centimeter, and 81 square centimeter, 81 square centimeter. If a side of the smaller triangles, if the side of the side of the smaller triangle if side of the smaller triangle is 12 find the corresponding side. Find the corresponding side. Find the corresponding side of bigger triangle. Answer. The areas of two similar triangles. Again, it is very, very important. What is given? This word is important. Okay. Are 225 square centimeter and 81 square centimeter. If the side of the smaller triangle is 12, then find the corresponding side of the larger triangle. Okay. Now you will find here, students, if this is 225, this is 81. If I take A1 is equal to 225 and A2 is equal to 81, so A1 is greater than A2. A1 is greater than A2. Fine. Then areas of two similar triangles are 225 and 81 square centimeter. If the side of the smaller triangle, okay, is 12, S1 is greater than S2. S2 is the side of a smaller triangle. So you will find here A1 upon A2 is equal to S1 square upon S2 square. Theorem on areas of similar triangles. On areas of similar triangles. Theorem on areas of similar triangles, that is A1 upon A2 is equal to S1 square upon S2 square. Fine. Then areas of two similar triangles are 225 and 81. So 225 upon 81 is equal to S1 square upon S2 square. 225 upon 81 is equal to S1 square upon S2 square. Correct? Now you will find if the side of the smaller triangle is 12, S2 is a side of a smaller triangle. So 225 upon 81, that is equal to side of a smaller triangle is 12. Area is proportional to the square of corresponding sides. So 225 upon 81 is equal to S1 square upon S2 square, and we have taken this S2 as 12, which is side of the smaller triangle. Okay, 225 upon 81 into 144, that is equal to S1. Try to understand. 12 square is 144. I transfer it to the left hand side. So 225 upon 81 into 144. Now, question is find out the corresponding side of the bigger triangle. So I'll take square root from both sides. The reason being that these all are square numbers. These all are square numbers. So taking the square root. From both sides, 225 15 upon 9 into 12, that is equal to S1. 15 upon 9 into 12 is equal to S1. 15 upon 9 into 12 is equal to S1. 3 3s are 9. 3 4s are 3 5s are 15. 5 4s are 20 is equal to S1. Therefore, side of the bigger triangle, is 20 centimeters. Okay, now try to understand again. Areas of two similar triangles are 225 square centimeter and 81 square centimeter. If the side of the smaller triangle is 12, find the corresponding side of the bigger triangle. Now you will find A1 I have taken it as 225. A2 I have taken it as 81. Of course, if this area is greater than this one, A1 is greater than A2, therefore naturally S1 is greater than S2. So A1 upon A2 is equal to S1 square upon S2 square. I mentioned over here. Theorem on areas of similar triangles. 225 upon 81 is equal to S1 square upon S2 square. So S1 square, side of the smaller triangle is given as 12. So 12 square. I transfer this to the left hand side. I got it as 225 upon 81 into 44. You will notice one thing very interestingly, that all these sides on left hand side, these all are perfect squares. So taking square root from both sides, I'll get this as 50 upon 9 into 12. So after this cancellation and all, I got S1 as 20. But what is S1? S1 is a side of the bigger triangle, and that is 20. So this is how you will find that 5 questions I have covered up over here. I have also explained a very important theorem, that theorem on areas of similar triangles. I am very much thankful to all of you for listening to this lecture. Carefully try to understand the very important concept that triangles must be similar. Then and then only we can apply this theorem on areas of similar triangles. Thank you very much, dear students.